Okay. I'm glad I checked that before we got started. Oh my God, that's me right in front of the camera. Okay.
Oh yeah.
My face.
Oh.
Okay. Now we can hear each other.
You
Perfect.
want to try a test?
Yeah, I can hear
Okay.
on the live stream, so we
Okay.
are all good now.
Great.
Yay!
What in business?
I thought one of my guys did it on me. But luckily they had a couple. So we're excited. A lot of people to meet. Yeah. Make some good connections. I went to my first one in 2014 and we were in Jacksonville. So years left.
Good to spend time with like-minded people. Hey, I'm Mohammed. Good to meet you. I'm doing the best speak. Happy to do it.
Introduce myself real quick. My name is Mike Williams. Mike Williams, president of Country Boy Marine. First year as president of FMCA. I appreciate everyone coming out. So this being my first year, if I stumble through a few things, just deal with me, and we'll get through it. Want to say we called an audible. Our OSHA presenter called on Wednesday afternoon and told us he could not come because he has COVID. And instead of having me stand up here for an hour and trip over OSHA standards and put you to sleep, I would call the old friend of mine, Muhammad, and ask him if he could come do a presentation. He did one I saw about 15 years ago when I worked at Orion, and I thought it was very palatable. So, Muhammad Hussein, professional engineer, is a life member of the American Society of Civil Engineers. He's a principal engineer at GRL Engineers Incorporated and executive director of global industry relations at Power Dynamics. Power Dynamics is the world's oldest and largest specialty deep foundations testing services and testing equipment manufacturing companies, respectively, with offices nationwide and representatives worldwide. In his 40-plus year career, he has consulted on more than 1,000 projects in 35 states in the United States and several countries, but mainly here in Florida. He teaches the two-day-long American Society of Engineers continuing education class in deep foundation design, construction, and quality control. He is the past chairman of the Deep Foundations Committee of the American Society of Civil Engineers, Geo Institute from 2002 to 2009, and the Power Driving Contractors Association Education Committee, and currently chairs the Power Driving Association's Technical Committee. He is also the recipient of several professional and industry awards and recognition, published over 60 technical papers and 10 engineering books. He has achieved expert level certifications and is a registered professional engineer in several states, which goes to say he knows a lot more than that. Muhammad, if you would.
Thank you very much, Mike. Thank you. Appreciate it. And good morning, everybody.
Good morning.
I will, first of all, thank you, Mike, for the invite. I'm honored to be given the opportunity to speak to you today. I'll try to make the next hour or so of your time worthwhile. I'll try to make it interesting and hopefully useful to your practice when it comes to deep foundations. I'll be talking about what type of deep foundations there are and what kind of testing there is to test them with. Deep foundations have actually been used for thousands of years. Herodotus mentioned them 2,500 years ago in his famous book, The Histories. That book is still in print. You can buy that book now, written 2,500 years ago. And Herodotus talked about the use of driven piles for marine structures. Now we have buildings that are hundreds of years old, founded on driven piles, still in use. And the one up there, that bridge is from Venice. Venice is the ultimate marine construction. They say that there are more than 1 million piles supporting Venice all over water in marine construction. If you want to see the advancements in deep foundations over the years, in 1648, they used 13,659 piles to support this building in Amsterdam. In 2010, they built the world's tallest building, 160 stories high, founded on only 194 piles. Just amazing what we can do nowadays. In today's practices, deep foundations are used to support all types of structures in all kinds of geotechnical conditions to resist all kinds of load combinations. They consist of driven piles, and by the way, there is a 3-volume manual on driven piles, design construction of driven piles, issued by the United States government. This is the standard, this is the state of practice, the state of the art in driven pile foundations. You can download it for free. This manual was written by engineers in my company, GRL engineers, that is used by all highway departments, by the Federal Administration offices nationwide. I'm going to leave you my email address at the end of this presentation. If you are interested in this manual in PDF form, please send me an email and I will send you the link to it, as well as auger cast piles and drill shafts. So there are manuals for all of these that I can send you links to, and I'll be talking about all three types of deep foundations in this presentation. For the longest time, by that I mean thousands of years, piles were mainly timber piles, nothing but timber piles. For thousands of years, until relatively recently, like the last 100 years or so. Now we use timber, concrete, and steel piles. There is a manual you can download for free also from the Timber Piling Council on the design and construction of timber piles. Timber piles nowadays are used for supporting all kinds of structures as well over water. They are also used as a ground modification technique where they drive these piles into the ground to improve the load-bearing capacity. Steel piles come in two varieties, H piles and pipe piles. Up until about 10, 15 years ago, we used to have about a dozen size standard profile H piles. Since then, they have doubled that. So now we have piles that are extremely huge, up to 18 inch in size and 200 pounds per foot. Imagine 200 pounds per foot of piling. So that is a very, very hefty pile that will be able to support all kinds of high loads, not only axial, but also for lateral support. Pipe piles come in a variety of sizes, ranging in diameter from a few inches, they call it micro pile or mini pile, to a foot or two, to maybe 5 feet, to maybe 15 feet in diameter. So all kinds of sizes are available, as well as length. Some of these pipe piles can be 1,000 feet long, 1,500, 2,000 feet long for offshore marine applications, for, let's say, oil rigs and natural gas rigs out in the ocean. Concrete piles, by that we mainly mean pre-stressed concrete piles. Specifically, almost always square pre-stressed concrete piles. The strength of this concrete is about 6,000 psi concrete strength. We may also have some post-tensioned spun concrete piles that have higher strength and larger in size typically. The strength of these may be 8,000 psi. The newest application of concrete in piling is the use of ultra-high performance concrete, the strength of which is up to 25,000 psi concrete strength. This is the very first such pile driven anywhere done here in Florida. Piles are typically uniform and prismatic, but not always. They can be highly non-uniform in cross-sectional profile, as well as composite of concrete and steel, different combinations of materials and profiles, depending on the application. For your application, probably for marine construction, this one on the bottom left-hand side may be of interest, where you can drive this 24-inch or whatever size concrete pile square as a load-bearing, axial load-bearing element, and then you can slip these panels in between it for containment. There are literally hundreds of different hammer models of all sizes, of all makes, of all models and operations. They can be hydraulic, air, steam, diesel, single acting, double acting, small, large ram, high stroke, short stroke, big ram, all kinds of hammer combinations that may be used. So when we drive a pile into the ground, the pile experiences a dynamic pile driving resistance. However, when we use it to support a structure, we need to know its static load-bearing capacity. There is a difference between the static load-bearing capacity of a pile and the dynamic resistance it experiences during initial driving. The best way to evaluate the static load-bearing capacity of a pile is to perform a static load test. So static testing can be done in one of two ways, either using dead weight or reaction piles, or sometimes a combination of these two systems. So to perform a static load test, we need a hydraulic jack and a reaction beam. The reason we need that weight is to hold down the reaction beam as we load that pile with that hydraulic jack. Then we plot, as we perform that test, we plot the applied load, the incremental applied load, and corresponding incremental displacement of the pile top. So this would be a typical plot of a static load test result, showing pile top load versus pile top movement. This is why we perform it. Please keep this in mind. I will revisit it later on in the presentation. So this is the standard type of output that we get from a static load test. Additional to that, we may want to put strain gauges along the length of the pile embedded in the ground. So when we load the pile at the pile top, we can also measure the shedding of the load, therefore the resistance, along the length of the pile by measuring the strain or the load in the pile with these strain gauges. This allows us then to estimate how much skin friction we have and skin friction resistance distribution on the pile length and how much end bearing we have. So although it is the best thing we can do to evaluate the load bearing capacity of a pile, it has limitations. Limitations of cost and time. It costs a lot of money to perform a static load test, and it takes a lot of time. Also, one have to keep in mind aspects of safety when we pile up so much load on top of a pile to perform a load test. Whether we use a dead weight or a reaction pile system, we may still have issues with potential failure during the test. So the challenge that we have is, can we come up with a way to evaluate the static load bearing capacity of a pile from its dynamic resistance during installation? Can we in fact equate the pile driving resistance as typically measured by blow count and blows per foot of pile driving and how many tons a pile would be able to carry? Can we in fact quantify this non-linear relationship between pile driving blow count and pile static load bearing capacity? Is there a way to do that? Engineers involved in pile driving for a long, long time now have realized from common sense that the more energy it takes to drive a pile, the more effort, the more work it takes to drive a pile, the better the pile would be, the more load it should be able to carry. So Mr. Wellington in the late 1800s wrote, in 1888, wrote a one-page article in the Engineering News magazine equating that energy of the pile by way of weight of hammer and drop height and the blow count and load bearing capacity of the pile. So that was done in 1888. Since then, a lot of people tried to improve on that, tried to adjust it, tried to accommodate it for the new technologies. Because back in 1888, we only drove timber piles, nothing but timber piles, nothing but drop hammers to very light loads. So now, of course, we have much more complicated systems. So people try to improve on that. But of course, you know, using 1800s technology in today's practice is not very efficient or very good. In the 1940s, another very smart engineer called Mr. Smith, realizing that what does happen during the impact of a pile driving hammer, and realizing that it is a problem of wave propagation. So when the hammer hits the top of the pile, it generates a stress wave, a shock wave, a compression shock wave, a stress wave that travels down and up the pile. Very, very fast, like at 15,000 feet per second, but it's finite. So Mr. Smith, realizing that and knowing the formula, this formula describes the one-dimensional elastic propagation in long elastic bars. It applies to pile driving. It applies to heat transfer, for example. If we have a very long steel rebar and we take a torch and we heat up the one end of it, that heat transfers along that bar in accordance to that wave propagation that is described by that wave equation. So this is the wave equation describing that. Mr. Smith wrote a computer program to apply this wave equation to the fundamentals of dynamics of pile driving, utilizing stress wave mechanics. It sounds like I'm saying a lot here, but the point being, this is the first application of digital computers in civil engineering. The very first computer program ever written in civil engineering was this program written in 1948 by Mr. Smith to follow the stress wave along the length of the pile so that we can actually relate the pile driving blow count and pile load bearing capacity. So Mr. Smith wrote that program for in-house use at the Raymond Company. The United States Highway Department heard about it, and they commissioned our group in Ohio to write a public domain program back in the 1970s. In the mid-1980s, the government said, you wrote the program, if you want to commercialize it, we don't want to support it anymore. It's well known now, everybody uses it, but we don't want to support it. Go ahead and commercialize it if you like. So we took it over, it's our own program, so now the commercial version of it is called GRL-WEAP. That is the dynamic testing, the dynamic analysis program that is used worldwide, everywhere. to analyze the dynamics of pile driving. It's a very powerful program because it allows for a relationship between pile driving blow count and static load bearing capacity. So if we know how much design load the pile is supposed to have, let's say the pile is supposed to have a design capacity of 500 kips. We know we have to drive it until we get, so many blows per foot. That way the inspector on the job site can use this unit called the saximeter, which means a meter of sound, and listening to the hammer and counting the blow count, blows per foot, to make sure that the inspector uses that as a quality control and quality assurance that every pile would be driven to the required blow count to achieve the required ultimate load bearing capacity. Very nice. It's a very powerful way of doing quality control on the pile driving. However, to set up that model in the program, remember it's a simulation. We're simulating pile driving in the computer analysis in the program. For that, we need to use assumptions. We have to assume a bunch of stuff, information, parameters, models. We have to model the system by utilizing assumptions. Because of that, the analysis itself has potential sources of error. So the people who wrote the program, knowing that they need assumptions to set the model up in the analysis, got to thinking, what if we were to go out there on the job site and take measurements? What if we were to measure what we need to know instead of assuming it? These included Professor George Goebel, the one up there in the leads, assisted by graduate students Dr. Frank Rauschi and Goran Likens, under a program between 1964 and 76 in Cleveland, Ohio, at Case Western Reserve University, funded by FHWA, FDOT, and all kinds of highway departments. They invented the whole idea of dynamic pile testing. They invented the whole principles, they invented the instrumentation needed, the sensors, the computer, the science, the engineering, the formulas that are needed to analyze all of these measurements. So that is what is now known worldwide as dynamic pile testing, utilizing the pile driving analyzer for field measurements and corresponding data analysis using the CAPWAP program. CAPWAP is a computer program, case pile wave analysis. It's a wave analysis program, but rather than relying on assumptions, now it uses the measurements on the job site as an input to the analysis of the program. Let's start from the very beginning. I just said that static load testing is the best thing you can do. That's a static load test. We need all of this dead weight to perform a static load test. What if we were to think differently? What if I was to take a very small portion of that, a very small percentage of that dead weight, put it in a guide, lift it up high enough, and drop it in such a way that that will give me the same load on the pile as all of that dead weight. I can engineer that, right? I can figure out how much weight I need to have, how high I should drop it, so that I get the same load on the pile that way instead of doing all of that dead weight process. That is basically the difference between static testing and dynamic testing. As it turned out, I don't have to do any of this. You, the nice contractors, do that for free for me. It's a pile driving hammer. So during the installation of the pile, the impacts of the hammer are providing the loading I need to do the test. All we have to do now is to put some instruments on the pile and take measurements under the impacts of the pile driving hammer during pile installations. These instruments will measure the load and the movement of the pile. The load is measured with a strain gauge, and the movement is measured with an accelerometer. Remember what we did with the static load test. We measured load and movement. We're doing exactly the same thing now, measuring the load and movement of the pile under the impacts of the pile driving hammer. There is an ASTM standard for this testing procedure called ASTM D4945. Dynamic testing can be done with the testing engineer and the PDA unit, the pile driving analyzer, on the job site, right there next to the hammer. During the driving of the pile, the testing engineer is there to do the testing. Alternatively, this testing can be done completely remotely. The engineer can be in the office, and then testing can be done on the job site in real time using SiteLink technology. So dynamic testing, therefore, is nothing but the measurement of pile load and movement under the impact of a pile driving hammer, and the analysis of these measurements using stress wave mechanics. These instruments are reusable, and they can be attached to any kind of piling. Pipe, H-pile, concrete, timber pile. These are very small instruments, 3 inches long. And they can also be attached to cast in situ deep foundations like auger cast piles and drill shafts for testing also. So when the hammer hits the top of the pile, it generates that shock wave, that compression wave that travels down the pile length. When that wave goes past the gauge locations on the pile, the gauges will sense a quick rise in pile force and movement. Then the stress wave goes by that and gets to the bottom of the pile, reflects and comes back when the gauges feel it again. They sense it again. So this, therefore, is a record of one test data. Every impact of the pile, every impact of the hammer on the pile produces this kind of data that is captured by the gauges, which includes impact at the pile top and reflection from the pile bottom. So this is the test record. We're going to take one of each for each and every hammer blow. In this case, it took 1,813 blows to drive the pile. So we have 1,800 tests on this pile during its installation. We can categorize all of that. We can put it in table form. We can put it in graphical form. So this is penetration depth, and this is static load bearing capacity of the pile versus depth, and this is blow count in blows per foot versus depth. So now we have everything we need to know. We know the blow count versus depth, and we know the static load bearing capacity versus depth, in addition to a lot more information, including hammer performance, pile performance, and soil performance. Hammer performance is extremely important because we are using the blow count from the hammer, so many blows per foot, 50 blows per foot, 30 blows per foot, whatever blows per foot we are driving with, we're using that blow count to correlate to the load-bearing capacity, to the resistance of the soil and load-bearing capacity. Except that that blow count is not only a function of the resistance of the soil, it is also affected by the performance of the hammer. That affects the blow count. So how do we figure out what blow count means for capacity if we don't know what the performance of the hammer is? We have to measure that. We do that by measuring the energy that gets to the pile. Now let me ask you this. If I have a hammer with a rated energy, maximum energy, how much of that energy do you think gets to the pile, percentage-wise? How much percentage the pile actually sees as a maximum energy of the hammer? Say a number, any number. Mike? 60%. You? 50%. It could be anything. This is a compilation of thousands of projects all throughout the United States. It could be 10%, 20%, 30%, 50%, 80%. It could be anything. Now, why does it vary so much? It varies so much because that depends on the mechanical condition of the hammer, the state of maintenance of the hammer, the condition of the cushions inside the hammer itself, and the cushion on top of the concrete pile. All of these play together into that variability. It doesn't matter what it is as long as you know what it is, because then you can quantify the performance of the hammer so that you can make sense of the blow count in as far as evaluating it for load-bearing capacity. We just have to quantify that hammer performance. So that is done for each and every blow of pile driving. During the impacts of pile hammer on the pile undergoes a very complex state of stresses that includes compression, tension, shear, torsion, bending, and buckling. Every possible combination of stress you can imagine, the pile will experience, up to the maximum strength level, repeatedly, 1,000 times during pile driving. So, how do you think the pile feels about all that? We were curious. We got to that pile. Hey, pile, how do you feel about that? Not so good. It shouldn't be really surprising because of the process that we go through in driving these piles into the ground. Piles get damaged at the pile top, which means that the hammer is too big. When the hammer hits at the pile top and the pile top crushes, it's not the material, it's not the wood, it's the pile hammer combination. So that's too much energy. By taking measurements on top of the pile, we know how much stress we have. We can control the energy of the hammer to lower the level of the stress in the pile to avoid damage. We do that by lowering the stroke and or increasing the cushion thickness in the case of concrete piles. So it is a measurement that we take at the top of the pile. It's a dynamic measurement, which means that it's a measurement over time. By the way, that time I'm talking about, that between impact and reflection, that is like 20 milliseconds. Very fast. But finite, computers can handle that. So it is a measurement on top of the pile versus time. We know how fast the wave goes in the pile. So now I have time and speed. Time and speed, I can go back to distance. Distance, time, and speed are linearly related. So if I know time, which I'm measuring, I know the speed, depending on the material, I can go to distance. Therefore, from the measured data at the pile top, we can calculate the stress level at any location along the pile length. At any location X, we know how much stress the pile has from the top measurements, including X equals L, the full pile length. So when we drive a pile into the ground, if we're driving it to a very hard end-bearing layer, the stress at the bottom of the pile could be twice that at the top of the pile. Because at the top of the pile, when the hammer hits the top of the pile, we have so much stress, right? So much compression stress. That compression stress travels down the pile length to the pile bottom. It activates an equal and opposite reaction from the rock. Both in compression, they both add up at the bottom. So therefore, the bottom stress could be twice that at the top of the pile. This is a project that they drove all of these piles into very, very hard rock. Supposedly, these piles penetrated differently into that hard rock, but not really. After extraction of some of these piles, look at the bottom of the piles. This is an illustration of the doubling effect in the stress as it happens as I drove these piles blow by blow by blow by blow. So when we drive a pile and we have end bearing, we know what happens at the tip of the pile. Let's say we are driving a pile without much resistance, like early driving. Not much resistance. That compression wave on top of the pile travels down the pile length, compression, 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 gets to the bottom of the pile, tries to pull the pile down. By pulling down on the pile, it elongates it, puts it in tension. If we're driving a concrete pile and that tension was too much, the pile will crack. All of these cracks and damages will send back wave reflections in the data that can be evaluated for location of damage and amount of damage on the pile for each and every blow. Remember, this is happening, the performance of the hammer, performance of the pile, stresses, integrity, so on, between hammer blows. The hammer runs at about 50 blows per minute, approximately one impact per second. Every second, we have a test done, and we have results available immediately within that 1 second. This is some data showing partial damage in the concrete pile. If the pile tried to walk, we're going to have partial damage on it, just on the one side. Or we may have complete damage on a pile, in a concrete pile, or a steel pile. And that damage on the pile will be indicated in the test data. Remember, impact at the top of the pile, reflection from the bottom. Now we have that from the bottom down here, but we also have an early reflection from right here. So that data indicates the amount and type of damage. So we talked about hammer performance and pile performance. Now let's talk about soil performance. Remember, all of this happening within that 1 second before the next blow comes. When the hammer hits the top of the pile moves into the ground. As the pile moves into the ground, it activates soil resistances in skin friction and end bearing. These soil resistances also generate a stress wave that goes up the pile. So now I have two waves on the pile, the wave going down from the hammer and the wave going up from the soil. Both of these waves get captured with the instruments on the pile that the PDA sees. So under the impact of the hammer, we have the wave going down and the wave going up from the soil. From these waves then, we're able to tell how much skin friction we have along the length of the pile and how much end bearing we have during each pile driving hammer, during each penetration depth. Since this is so convenient to do, so we'll test the pile during initial driving and later on in time. When we drive a pile initially into the soil, we disturb the soil, we weaken it. So we have so much capacity. But over time, the soil consolidates, grabs onto the pile, the load-bearing capacity increases in a process called setup. So the pile soil setup, which means it increases capacity. In this case, within 30 minutes, the capacity increased from 200 to 280 tons. Free capacity in half an hour. So that's the good news. That's what happens in most cases, but not always. Sometimes the pile capacity actually decreases with time in a process called relaxation. So under certain circumstances, conditions, pile soil interaction type, the capacity will decrease in time. This process is known to happen in Florida. So we can plug that information then into the CapWeb program that we measured with the PDA, utilizing some sophisticated engineering modeling and analyses, the end result of which now we can simulate the static load test result. From the PDA measurements and the CapWeb analysis of the data, we can simulate static load test result. This is when I ask you to remember that plot from the static load test. I'm going to revisit. This is it. This is a simulated static load test, load versus movement of the pile without doing a static load test, simply from the dynamic measurements under the impact of the hammer. Well, how good is it? How does it compare to an actual full-scale static load test? Over the last 50 years, there have been many, many correlation studies by professionals, by highway departments, by universities, by dissertations, by students that look into this correlation. I'm going to only show you two cases, since we're in Florida, from Florida, that were published by the American Society of Civil Engineers. This is a job not far from here where they did both static load testing and dynamic testing. And this is a correlation, excellent correlation. There's another job up in the Panhandle that also shows a good correlation between the simulated from dynamic measurements and full-scale static load testing. So if the data quality is good, if the analysis is done properly, one can expect to have excellent correlation between just a static load test and a dynamic load test without having to run a full-scale static load test. This type of dynamic testing is typically applied on projects by way of a test pile driving program. The design engineer will designate a number of piles on the project, a handful of piles, go ahead and hire the contractor, drive the test piles, and dynamically test them. The purpose of that program is to establish production piles length for the job, establish a pile driving criteria for the project, check the engineer's design assumptions, and also check the contractor's equipment and means and methods to do the job. This has been the way for 50 years. Recently as this year, in Florida, the FDOT decided that they want to do 100% testing on each and every pile. Each and every pile driven in the state of Florida for the DOT is dynamically tested, 100%, with or without a test pile driving program. They found out that that process of 100% testing, all of these projects were done with 100% testing, including the Pensacola Bridge next to you there. So that was a lot of testing there. They realized, or they figured out that the process, doing 100% testing, optimizes construction efficiency and economy and increases engineering reliability. Now the design engineer knows by verification of testing that each and every pile on the job is verified for load bearing capacity and integrity, which would allow for the use of a much lower factor of safety and design, which will make the foundation a lot more efficient and economical. On the flip side to that, however, one would have to predetermine the production pile length for the job without the benefit of the information that one would obtain with a test pile driving program. In many cases, this works fine. In many other cases, not, especially in Florida, because it's very difficult to predict the length of the pile without actually checking it because of the geology that we have and the karst conditions that we have. So that was the discussion on driven piles. Next, I will move into deep foundations that are cast in place, cast in situ, starting with auger cast piles. Auger cast piles have traditionally been used to support structures, buildings of all sizes. Most of the buildings in South Florida, East and West Coast, high-rise, these tremendous buildings are mainly founded on auger cast piles. Recently, they are now being used on bridge foundations. This is how an auger cast pile is installed. They install it, the contractor would have a continuous flight hollow stem auger. The design engineer will determine the depth, so the contractor would drill down to that depth and would draw the auger. During the auger withdrawal, pushes grout through the bottom of the hollow stem. And by the time the auger is all the way out, we have a hole full of grout. Then we'll bring the steel cage and push it down it. The steel cage comes last, is pushed down that grouted hole. That was the conventional way. A newer way is called a displacement type auger cast pile. Notice that at the bottom of the auger, they reverse the direction of the flights. That way, we're not mining the soil, we're not taking soil out of the ground, we're actually pushing it, displacing it in the ground. So displacement type auger cast pile. This has many, many advantages. Not only it improves the geotechnical conditions, but if you happen to have a project where the soil is contaminated, taking any ounce of soil out, you have to process it. In this case, you don't worry about it. It's always still down there where it is. These rigs to install these piles are typically fitted with equipment that measures while drilling. The hottest topic in engineering now at the University of Florida and everywhere is research on MWD, measurement while drilling. Take measurements of torque, pressure, grout pressure, depth, volume, all kinds of information to make sure that each one of these piles is done properly. Drill shafts, on the other hand, are also cast in place deep foundations, but very different than auger cast piles. Typically characterized by much larger sizes, while auger cast piles can be, 12-inch, 16, 20, maybe 24, up to 36-inch. These are the largest I know of, 36-inch in diameter auger cast piles. Drill shafts start at 36-inch or 48-inch, and they go up to 3, 4, 5, 6, 8, 10, 15 feet in diameter, and they can be 100 to 100 feet deep. By the way, the very first high-rise skyscraper invented was in the United States, in Chicago. This is it. This is the very first skyscraper in Chicago in 1885, 10 stories high, steel frame building. That was founded on hand-dug deep foundation. They actually sent people down there, all the way down there. And then they may have a bell on top of it. So now they have this hand-dug, 100 feet into the ground foundation for these buildings in Chicago. And they actually held a meeting down there, a progress meeting in the bottom of their hole. The engineers, they sent the engineers there. The very first use of drill shafts recorded was in Texas in the 1930s as an outgrowth of oil exploration. So they would get this rig, drill, they would drill for oil. They found oil, great. If not, well, now we have a hole drilled. So they decided to put a steel cage in it and fill it with concrete. That was the original beginnings of drill shaft construction. FDUT took that in 1950 and became standard practice for the Texas DOT for their bridge foundations. The very first major application or use of drill shafts in Florida came in the 1980s following the disaster in St. Pete for the Sunshine Skyway Bridge. Remember when the barge hit it? The new construction of the new bridge is founded on drill shafts. So to construct the drill shaft, we may have to, because of a water table, we may have to use a casing, steel casing. Steel casing temporarily during construction or permanently as part of the constructed shaft. We may also want to use slurry. So slurry is a thick fluid that we put into that drilled hole to apply hydrostatic pressure inside that hole to keep the soil, the wall of the hole, from falling in as we construct that drill shaft. But that has to be done extremely carefully. That is why there are so many tests required on the slurry during the construction of the drill shaft. Because the slurry, to have its density, it has to have certain density because the pressure, the lateral pressure it applies, the hydrostatic lateral pressure, is a function of the depth, which is the depth of the hole, and density. So we have to adjust the density sometimes by putting sand. If we put too much sand, then the sand will settle at the bottom of the hole, so we're going to have a soft bottom. So the shaft will then suffer from end-bearing resistance. We're going to have a bad shaft end-bearing resistance if we do that. Also, that can also stick to the side of the hole, which will provide then a slick plane between the concrete of the shaft and the soil. So we're not going to have any skin friction either. So that will affect the load-bearing capacity of the shaft. That's why they do so much testing of that slurry, expert testing. So now we have a hole, 100 feet deep hole full of slurry. We have to fill it with concrete. We do that from the bottom up. We do that with a tremie pipe, which is a very long pipe with a hopper up on top. We put the concrete in it. We take it all the way down to the bottom of the hole and start pouring concrete and picking it up a little bit at a time until we're all the way up on the top. Meanwhile, collecting that slurry up on top. That is not so easy to do because we have a hole full of slurry we can't even see down there. And the tip of that tremie pipe must always be in the concrete. It cannot breach it, otherwise we're going to have a problem with the constructed shaft. But we can't see where the top of the concrete is because of the slurry. We don't know where the bottom of the pipe is, but it all has to be done properly. We're constructing something 100 feet in the ground in the blind. We can't even see what we're doing. Also, the design of these things, the steel cage and the concrete have to be done properly so that the concrete will flow out through the cage and engage the side resistance for load-bearing capacity friction resistance. So when we drill that hole, before we do anything to it, only the hole itself we have to test it for a few things. We have to test it for profile, the profile of the hole, and plumbness, verticality. We're drilling a hole 100 feet or more in the ground. It has to be perfectly plumb all the way through, within very little tolerance, like 1, 2, 3, 4 at most, 4%. We also have to test it for cleanliness and competency at the bottom so that we can have end-bearing resistance to the drill shaft. All of that before we put the steel cage and before we fill the hole with concrete to make the shaft. The profile of the hole and plumbness, verticality are tested with this shape equipment that sends, we send it down the hole and up real quick. It sends signals for reflections, like a radar type thing, and it gives us a 3D picture of the hole. It will also give us the offset between the top of the hole and the bottom of the hole to make sure that the plumbness requirement is met. It will also calculate the volume of the hole. That is important because later on, when we fill this hole with concrete, we make sure that we have enough concrete in that hole, at least equal to the volume that we drilled, not the theoretical volume from the size of the drill, because the hole could be different. The bottom cleanliness of the hole and the competency of the material at the bottom to make sure we have good end-bearing resistance on that drill shaft are tested with this equipment called SQUID, Shaft Quantitative Inspection Device, that has 3 little probes at the bottom, and they probe the bottom of the hole for stiffness, strength, and thickness of the bottom of the hole. Typical requirements is that the bottom of the hole should not have any more than half-inch thick soft material on less than half of the area. So the area bottom of the hole is probed and tested that way. So we do the best we can with the inspection and testing and the construction. We put the concrete, everything is happy, everybody's happy, everything is looking good, perfect. Well, maybe not perfect, but okay, not perfect, but good enough. But sometimes it can be very bad. Remember, we're constructing something in the ground, in the blind. There are many factors that affect the integrity of these cast in situ foundations in the ground: subsurface conditions, design, installation means and methods, and workmanship. Expertise is really needed to do that properly. There have been many studies at different universities, highway departments, and many different places. The bottom line is that everybody agrees that a good number of these cast-in-place piles have some kind of an issue that ranges from flaw to defect. The oldest way to test for that was started maybe 40 years ago. 5 minutes? Oh, I thought I had an hour. Oh, okay. No, I have, okay. Maybe I have 15 minutes. 10 minutes, okay, very good. So I'll speed through it. So what I want to get to is that well, I'm a substitute, so. So another method is the CSL testing method, that we put probes in the shaft and we send signals and we get results. So this is a good result, and that's a result showing a bad shaft in the middle, and the other one is bad shaft in the bottom. What I want to get to is to show you the newest technology in the analysis of drill shaft integrity, which is the thermal integrity profiling, invented here in Florida, University of South Florida, and we took it over to commercialize it 10, 15 years ago. We measure the temperature of the concrete during the curing process in the ground. It had won so many innovation awards, and this is how it goes. We're going to put these thermal wires along the length of the shaft and take temperature every foot around the circumference of the shaft. Also, we're going to tell if there's a shift of the steel inside the concrete from the relative measurement of temperature around. That will allow us to draw a 3D picture of the concrete of the shaft on the ground and the location of the steel inside that concrete. So that is done completely automatically within the first 24 to 48 hours of casting of the auger cast pile or of the drill shaft. That will allow us to have the integrity assessment done early, and also to have the cover of the steel, of the concrete on the steel evaluated. So we talked about low strain testing with a small handheld hammer for integrity, and now we talk about high strain testing for load bearing capacity. For that, we need a big enough hammer. We have to hit the shaft with a drop hammer to move it, to activate resistance, to measure load bearing capacity, with the same technology as a PDA on drill shafts. So we do that and we get that simulation. I was going to tell you about this case history in Tampa. You all know about it, where the bridge actually collapsed and the foundation failed. It moved 11 feet into the ground. So we were brought in after the fact. We did some testing on these piers. Each pier sits on one shaft. We tested the pier and the shaft. This test here shows the shaft passed, the other one did not. They had to go back. There was 300 piers on that job, and they had to fix 100 of these piers at the cost of $120 million. And the job was done. It's a fantastic, fantastic project. So I was going to tell you about this is a conventional static load test. A very smart engineer, the one on the right, is Professor George Osterberg, said that instead of putting the hydraulic jack on top, what if I put it at the bottom of the shaft? And I load the shaft from the bottom up. So now we call that bidirectional load testing of these drilled shafts. This engineer is testing this shaft, full-scale static load testing, nothing there. Everything is buried in the ground. So this is how the test is done. We apply load at the bottom. We measure movement up and movement down, movement up and friction, movement down and end bearing, until we get to the full resistance of the soil. We can then take that data and convert it into an equivalent shaft top load displacement graph, as if we have loaded the shaft up on top. So all of these methods I outlined to you today, we started 50 years ago. Now it becomes standard practice worldwide. They're widely available in standards, codes, specifications, reference books, textbooks, journals, technical papers. There's no shortage of information on the technical background, application, limitation, cost, correlations of all of these test methods I outlined to you today. I just want to mention to you, I think you may be interested in the Pile Driving Contractors Association's Pile Academy in November 10th to the 13th in Mississippi. They're having a pile driving school there, where they're going to have pile driving hammers and pile driving people there talk about pile driving. I highly encourage you to check into that PDCA and maybe go to it. And with that, I thank you very much for your time. I appreciate the opportunity to speak to you today. I hope you found the presentation, although a little bit hurried at the end, interesting at least, and hopefully useful. And with that, Mike, thank you very much. Anybody had any questions or quick comments? This is my email address, very easy to remember, mhussein@pile.com. Please send me an email, send me a note if you have any questions, any comments, or if you would like links to these manuals I mentioned. Thank you. Appreciate it. Thank you.
All right, guys, we're going to take a quick break. Our next presenter will be on faster. So I think they brought some beverages, maybe water or something. Take a quick break, and we'll be back here in about 5 to 10.
I'm going to take my computer.
I thought maybe that was theirs.
This is you have your own? Yeah, but you can set it up. Let me get out of your way. This is for the clicker. No, this is for the clicker.
I'm not using that.
Okay.
Listen, I just got back on vacation from vacation this week, so.
He stopped.
I appreciate it.
Yeah, he's gonna tell you about 10
I just want to introduce myself. Michael Vince with Henderson Pre-Stress
Hey,
Concrete.
how are you doing?
Good. We make piling and stuff like that.
I appreciate that. I know you do.
Love the presentation. That was great.
If you think of any other place I can present it, I'll be happy to do that.
Yeah, no, that's what you were given. I'm like, maybe we'll do this again. Have you do something with us next year here or something.
Well, not only here, but any other
Sure.
organization you may think of.
Okay.
Ashley,
You have a card with you, or
Yes.
I got your email.
yeah, I'll give you a call.
Can I help you with this?
Pardon me? No, I got it. Thank you. Let me give you my card.
Are you leaving right now? Or
Yeah, I'm going to take off.
Gotcha. Actually, I just remembered I didn't bring any cards.
Send me an email so I'll have your contact information.
Okay.
Thank
Sounds
you.
good. Thanks again.
Thank you. Appreciate it. Yes. Sometimes they have, yeah. I took everything I had.
Just want to take a moment just to thank the Florida Marine Contractors Association for the opportunity to present. I will tell you, I'm a little surprised I got this many people in here. I am a little surprised I got this many people in here that are interested in fasteners. After that presentation, that was incredible. But they are needed and they are critical on the projects that you are doing. And it's moments like these as a supplier, I kind of feel like the student teaching the professor. You guys are in the field, you know it, you understand it, you've been battling it for years, and I just appreciate what you do and what you know. First of all, I just want to give you an overview of who Threaded Fasteners is. I got a feeling that some of you in here aren't aware of us. Threaded Fasteners, it was founded in 1979 by brothers-in-law Frank Martin and Steve Schultes in Mobile, Alabama. From just a few employees to today, TFI has over 400 employees all across our locations. TFI is also an ESOP. We're an employee stock option company. We are all 100% employee owners. We have 17 locations across 7 states: Alabama, Florida, Georgia, Tennessee, Mississippi, Oklahoma, and Texas. There are 4 locations here in Florida: Tampa, Orlando, Panama City, and Pensacola. We have 4 manufacturing locations: Mobile, Alabama, Tampa, Florida, Dallas, Texas, and now Thomasville, Georgia. We have 387,000 square feet of combined warehouse and manufacturing space, 16 million in inventory, and 42 million individual parts. Threaded Fasteners' growth has been through acquisitions and organically starting new branches, which is what we did in Orlando 3 years ago. We have 4 additional companies in the Threaded Fasteners family, and they're listed here underneath. BBC Fasteners is located in Alsip, Illinois, where we manufacture A325 structural bolts. RTC Threaders, located in Churubusco, Indiana, and they manufacture planetary threaders. And what that means, it's a threader that has one thread die that can go, I keep losing this, that can go side to side for length. We can thread one end or we can thread both ends simultaneously with a planetary threader. We bought the company because we were buying the product and buying the threaders from them, and through the course of that came to the conclusion that they wanted to be with a company that would be advantageous to them as well. Quality galvanizing. We started our own galvanizing business back in 2018 in Mobile, Alabama, and we do our own in-house hot dip galvanizing. In fact, we have reached the point of capacity to the fact that we are now getting ready to build a second plant. And then SEF distribution. SEF was born from the standpoint of, if you remember all of the backlog of imports several years back, we decided that we wanted better control of that, so we decided to start a company called SEF Distribution, where we are now direct importing. We have 2 warehouses, Mobile, Alabama, near our corporate, and also in Tampa, Florida. Through ESOP ownership and servant leadership, our mission is to create value in and for the people we serve. Our core values are humble, hungry, and aware, and our strategic anchors are people development, custom solutions, and operational excellence. Threaded Fasteners also has a charitable foundation supporting the communities we serve. As we continue to grow, so does the foundation reach. What that means, every location, all 17 locations, we will reach out to that community and find nonprofits that we can support with our donations. Today, we are still in pursuit of acquisitions and organically growing threaded fasteners into new geographic markets. Now, fasteners. Before I get started on the product, I want to just give you some information. You may know some of it, you may not, on the stainless product. The 18-8, the 304, and the 316 stainless. From the standpoint of the chromium, 18-8 has 17 to 19%, and this is just based on average categories. 18-8 has 17 to 19% chromium, has 8 to 10.5% of nickel, and as far as carbon goes, 0.08%. Stainless 304 has 18 to 20% chromium, and if you look at that, to go from the 18-8 to the stainless steel 304, they basically overlap. 8 to 10.5% on the nickel and 0.08% on the carbon as well. And then when you get to the stainless steel 316, it has 16 to 18% of the chromium, and then 10 to 14% of the nickel, where you get the higher corrosion resistance. But here's the thing, it also has 0.08% on average of carbon. I'm sure you've run into situations where you order the 316, you put it into application, and you find rust. That's the reason why. You do have carbon in all three categories. Okay. As far as, let's see, docks, piers, and boat lifts, starting out with those products. All thread rods, grade 36 and 55, we do stock. Hot dip galvanized, stainless steel, 18-8, 304, and 316. 6 foot, 12 foot lengths, allows for field cutting to length. Nothing perfect about wood, concrete, steel, and water. It just is one of those things where you can cut the lengths in the field. All thread studs, grade 36 and 55, hot dip galvanized, stainless steel 18, 18-8, 304, 316. We can actually, in our manufacturing, cut, pre-cut to specified lengths. U-bolts, 1/2 inch up to 1 inch diameter rod, grade 36 and 55, hot dip galvanized, 18-8, 304, 316. Round bend U-bolt, 1/2 inch ID to 18 inch ID. Square bend U-bolt, 1/4 inch rod by 1 inch ID up to 1 inch rod, and literally we can take a 20-foot length and bend the bar to whatever designation. Just don't make it a 3 inch or a 6 inch opening there, but we can literally bend a 20-foot rod to a specification if needed. Through bolts, hex head A307 low carbon hot dip galvanized, hex head A593 stainless steel 18-8, 304 and 316. Carriage bolts A307A low carbon hot dip galvanized, and carriage bolts stainless steel 18-8, 304 and 316. Generally wood-to-wood connections. Lag bolts, hex head A307 carbon hot dip galvanized 1/4 by 1 inch to 3/4 by 12 inch. Hex head stainless steel 18/8, 304, and 316. I know this gets repetitive, but it is the industry. And we get these requests all the time, and I just want you to be aware that we do have this. The lag bolts, hex head A307 low carbon hot dip galvanized, 1/4 by 1 to 3/4 by 12 inch. Hex head stainless steel 18/8, 304, and 316 as well. Eye bolts, hot dip galvanized stainless steel 304 and 316, turned and forged. Brown flat dock washers, hot dip galvanized 1/4 by 3 inch OD. OG washers, hot dip galvanized for 3/4 and 1 inch diameters. Just curved plate washers, hot dip galvanized, domestic grade 36 and grade 50. Square plate washers, hot dip galvanized and stainless steel grade 36 and 50. Various thicknesses and size square. We also have recently purchased an auto shear and punch, which will be coming to the Tampa facility. Not sure when that date is, but it is on the way. Deck screws, marine grade, stainless steel 18/8, 305, and 316. Multiple manufacturers, finishes, coatings, color, and head drives. And then also standard finished hex nuts, hot dip galvanized stainless steel 18/8, 304, 316. The heavy hex nuts, hot dip galvanized 18/8, 304, 316. Silicon bronze hex nuts, dissimilar material to reduce galling. We carry that as well. Coupling hex nuts, hot dip galvanized, stainless steel 18/8, 304, and 316. USS flat washers, hot dip galvanized, 18/8, 304, 316. Lock washers, hot dip galvanized, 18/8, 304, 316. Structural hard round washers, L436s, hot dip galvanized. Bevel washers, hot dip galvanized, stainless steel 304 and stainless steel 316. Also, we have seawalls as a product that we supply. Well, if I can get there. Primarily tieback rods and plate washers. Tieback rods are both grade A36 and grade 55, hot dip galvanized, 12-inch minimum thread each end, 5/8 by 10 foot, 12 foot, 15 foot, 3/4 by 12 foot, 14 foot, 16 foot, 18 foot, 1 inch by 12 foot, 14 foot, 16 foot, 18 foot, and 20 foot. Plate washers, grade 50, domestic and low carbon import, 1/4 by 3 by 3, 1/4 by 6 by 6, and 1/2 by 6 by 6, hot dip galvanized. Whaler bolts. Carriage bolts, hot dip galvanized. All thread rods and studs, hot dip galvanized. Special forged bolts, largest that I have seen so far that we have supplied was a 2-inch by 30-inch hot dip galvanized to specification. That was about 10 years ago. Square plate washers, grade 50, domestic and low carbon import. Standard finished hex and heavy hex nuts, hot dip galvanized, to connect whaler support boards to the wall space between the rods. Concrete, new and existing. Double end stud anchor bolts, grade 55, hot dip galvanized, bollards and cleats. Not that we sell those, but for the bollards and cleats. new concrete assemblies, all thread studs, grade 36 and 55, hot dip galvanized, stainless steel 18-8, 304, and stainless steel 316. Heavy duty hex washer head screw anchors, mechanical galvanized, stainless steel 304 and 316. Wedge anchors and sleeve anchors, stainless steel 18-8, 304, and 316. And epoxy, above water, various. We primarily have Simpson and DeWalt. Underwater, various. Adhesive technology. Emergence Seal, Kaufman Products, Euclid Chemical, Zerite, and Loctite. The one time that I have seen that applied was on the Tampa River Walk when they had to do some underwater applications and were able to use the adhesive technology Ultrabond for underwater applications. Some additional miscellaneous items that you might want to consider are pipe hangers galvanized, turnbuckles galvanized, wire rope clips, hot dip galvanized and stainless steel, screw pin shackles, hot dip galvanized and stainless steel, and even chain. It all just depends on the project, what is required, and how it's being applied. I do have samples at our table of the products that I have mentioned here today. And that concludes my presentation. Do I have any questions about anything on the products? All right. Thank you very much.
Thank you, sir. All right, guys, we got a little extra time now till lunch. They're going to have lunch in the room. So take a break, relax, and we'll be here for lunch at 12.
Say quarter to, I think that they should be ready about between quarter of and 12.
Okay, hang tight, guys. We're going to have lunch here in this room, and then our next presentation will be at 12:30. Thank you, Kim.
Thank you. Glad to know you're on board with us. Yeah.
I've been participating for a while.
Yeah, awesome.
You didn't put your contact information up there. Do you have a card or anything?
I do. It's on the table. I don't have any on me,
No
Wayne.
problem. Let me get
Sure.
I buy quite a bit from Pinellas Fastener
Oh, okay.
and Tri-City Bolt over there. We're from the West Coast,
Sure.
but we're
Were
coming on
you
some
were you
pretty-
even aware of us?
Wasn't even aware of you. That's why.
That's the
I've been in
reason
business
I
about
did
30
that. That's the
years.
reason I did the first part of that. Sure. Yeah, we
Now-
would be
now,
very.
We've done quite a few federal projects and some county products and stuff that require made in the USA product, and I know you source as well.
Sure.
But do you guys like your screws and stuff like that? Are they sourced or you manufacture those?
Now,
If we
what
had
kind
to
of
be-
screws are you
If
talking?
you're looking like composite screws,
Oh no, yeah,
and-
that's source.
so everything's going to come from overseas, unless you do like Simpson or somebody.
Yeah.
Sorry to interrupt.
Oh, you need
Presentation, yes.
this thing out of my throat.
I do need the thing out of your throat. Thanks so much. Hey, it's not so cold now. All right.
Trying to figure out what the name of the next person is.
Oh, who's next?
Oops.
They have dessert out already. It looks so good.
Go ahead.
No,
We're in it.
not before lunch. Yeah.
dining area.
I know. For VIPs.
So how's everything at the bead store?
You know, it's going really well actually. Like I said, I only work there a day a week. But it's been going good. The new owner, Linda Davis, she just bought a, there's a gray building behind La Crepe de France. There's a crepe restaurant, like a French restaurant. She bought that building for her other business, Petals Florist. So she's gonna move her floral business downtown, so it's kind of all her assets, I guess, are concentrated in one area.
I'm sorry, I lost the form.
That's all right.
This is Maddie with Kind Designs.
Hi, nice to
Hi,
meet you.
how are you? Nice to see you. There you go.
Yeah, I don't know where I put the format. I lost it in that
That's
short
all right.
period of
Grab
time.
one of those, and then I don't know what I did with the pen.
What did we do with our pen?
Oh no, you're good. You're good. Everybody's eating lunch right now. You have a pen?
Oh yeah, it's right there.
Right there.
There we go.
The table's too
So if
small.
you can
I know.
put your name there and fill in down here and sign it. Okay. And it's just release them for the live stream. Okay. Yes. Or you can just put your laptop up there. Did you bring a laptop? Yeah, just use your laptop and hook it up. Everything's up front. Okay. Yeah, it's up there too.
And you're going to be the one giving the presentation, right? Okay, cool. When you're done with that, I'm going to hook you up with our little microphones.
Okay.
Jade?
I do. I need to go get my computer and stuff. So
Oh, that's
is
fine.
it okay if I?
Yeah, go get
I'll
that,
get that
come
and
back,
come
and then,
back?
yeah.
Is that a jade pendant you have?
No, it's not. It's not a jade. It's like I got it in Oregon.
I love Oregon. It's one of my favorite states.
I love it. I just went for the first time.
Oh, where'd you go?
I did a road trip. I started in Portland. I went to Bend, Crater Lake, Falmouth, like did the
Oh,
whole
yeah.
thing.
Oh, my God.
And
The
then out to
waterfalls.
the coast, seaside. And, yeah.
Oh, yep. Been there many times. It's great.
Are you from Florida? Or?
Yeah, kind of. I mean, yeah, I've spent most of my life here, but it's just, I think what I love so much about Oregon is, like, especially on the coast, you can see the mountains and they just drop off into the sea. It's just unlike anything I've seen before.
That for me, I'm from Vermont, so for me,
Oh,
getting some mountains is like essential.
yeah. Vermont is beautiful. I haven't been, but
So nice.
I would love to go.
Yeah. If you ever get the chance, it is hard to get out there though because there's not like really direct flights.
Yeah, no, there's not. I mean, it's too small, really.
Exactly. It's really frustrating, honestly.
Yeah.
Okay, here's the form. Thank you so much.
Thank you. And
let me get my computer.
yeah, no rush. Just come back and see me. Oh, do you have a jade too? Did you get? It looks like, you know.
But I bought it from the Vietnamese jewelry store.
Oh, wow.
The people that own Fo 88, which is a pretty old Vietnamese store. Not grocery store, noodle shop.
Oh.
And anyway, the owner of that also owned this jewelry store, and I used to go in there to the noodles all the time, and so then, you know, she told me she had the store, so I went over there. And for my birthday, I want to say it was around 2001, something like that. I bought it.
software, like inside programs and stuff like that. So this is it's really cool.
I also have a jacket if that makes it easier. I don't mind it. Yeah, sure. You'll go with tile. Yeah, you'll get concrete all over you. Yeah, I can give it to the broom like a podium and project. And he called me and was just like, oh, I'll actually be flying into Miami tomorrow morning. I know I've seen the facility. Do you guys have anything new? Can you pick me up from the airport? And I was like, well, I won't be there. And then he asked me, he was like, do you have any contractors that you would recommend for reef projects?
Of course you do.
And I said, Emerge Marine.
We were just talking about Monroe County State reef guy that contacted. They want to use some of the kind designs stuff in there, so
Yeah.
you may want to.
In Monroe County or
In Monroe for what we're
I
talking
was
about
talking to Hannah Coach last week from Monroe, and she has a site that thinks is perfect for like 3D printed infrastructure and stuff, and she wants to test some of it out there.
You know where?
The Gulf Side Network.
No, like what site?
I think it was Site 10.
Like where would that be located?
It's more closer into the bay.
Did you see the RFP that they sent out?
I didn't see it yet.
I'll send it over
Yeah.
to you just to see if.
Usually I get notices, but I've been driving the whole morning.
That's why I just wanted to listen to what you were saying.
Yeah.
She was already notified by the state and Monroe County before they were coming out. That they
Yeah,
wanted to
last week Hannah and I were talking, and she was like, yeah, we have an RFP coming out next week. I think it would be a good one for you guys to look into. I haven't looked at it yet, so I don't know. We don't work as the contractor, so,
But they asked her, do you have a contract before to work with?
yeah.
Of course, her buddy.
Yeah.
Of course, her buddy.
Yeah, so I was on the phone with Keith Mill from FWC yesterday, and he was asking if we had any new reef designs we were working on, because he was flying into Miami and wanted to see. And then he ended up being like, well, also, do you have any contractor recommendations? We're really struggling recently to find, yeah, or like just diversity of contractors.
What's the name of the gentleman?
Keith Mill,
Mill, M-I-L-L?
Mille, yeah, from FWC. He manages and oversees like their artificial reef program. He's a great guy to know. But I said Emerge Marine. I was like, have you heard of Emerge Marine? And I sent over his contact information, your contact information for him. Yeah. Because he was like, please send me their contact.
Speaking of that, I had a meeting, I don't remember, Anya introduced me, but it was your guy that does your designs and stuff.
Was it Diego or Emmy? Jeremy?
Jeremy, maybe.
Jeremy, yes.
But he had shown me a design, half wall, I didn't mean to interrupt your lunch, but that we can basically install without the king piles. I wanted to he didn't send me anything after we were done with the meeting, but I'd like to send something because we are going to be doing all the Selby stuff. Andy's type
With
of
the
this-
tongue and groove, right?
Yeah, well, I mean, it's not going to be tongue groove, but I get what you're saying. But
It's a similar type of
Right.
design, yeah.
But I'd like to get that over so that we can start at least that
Yeah.
part. What he said when he was mentioning, he says, well, we have some engineering development money that we can, kind of
Like our
put some
R&D,
program in.
yeah.
And I said, why? Let's have somebody give them a discount, but at least where you're not even putting your R&D money into.
Yeah.
Let's do the R&D at Selby because it's a shallow area. You saw it.
True.
I think it would be an ideal situation for
At
that
a
side
historic
seawall.
point where
At
they,
Spanish Point,
yeah, where they had that, yeah.
Exactly.
I think that'd be
So if he
great.
can send me, and whatever
Yeah.
you guys are comfortable with too, but
Yeah.
I think if we can send it, that we can send it to Selby to say, hey, here's our concept design for the seawall,
Yeah.
and then we'll give you some for the whatever else we're going to look at.
Yeah, let me write that down. Yeah, we can send you, do you want like a rendering of the site with the panels in it?
Yeah, and
Sean?
how we were going to put the panels.
Yeah.
With the design he's got there.
Yeah.
I think that would work there, and I told him we can even use that. Because at the end of the wall, you need to have a return. We can just turn the last one sideways and run
Just
it
put
as
it
a
in,
return.
okay. Do you just want like images and renderings, or do you want
I
like
think a
an
rendering-
engineering specs of it
I don't
right
think
now?
we give an engineering spec yet. I just
Okay.
want to give them a rendering that this
Okay.
is our. They were looking for ideas.
Yeah.
But again, technically, I guess they have to put it out to bid. But Andy's kind of.
I know.
So he,
Yeah. Yeah. Okay, and this is in Vero Beach. Okay. Yeah. Yeah, well, awesome. Yeah, no, I'm Rieger. Yeah. Oh, no, yeah, Rieger. So it's kind of difficult to say. Everyone says it cold up there, yeah. Yeah. That's me too, and my family. My dad actually just sold our house in New York. He's doing like 3 months there. He was just in Tasmania for 3 weeks. Yeah, I saw a video of him. He's just hiking around. He FaceTimes me. His legs are dangling off like a cliff. Yeah, I'm so jealous. But I'd love to chat after more too. Yeah, nice meeting you. Hi, good afternoon, everyone. Hello, it's nice to see everyone here today and always fun gathering with everyone at this event. Today I'll be talking a bit about Kind Designs and our 3D printed coastal infrastructure with living seawalls, what a living seawall is, how we manufacture it, how you install it, and how we work with contractors to bid on projects and make living seawalls come to life. And I am the project lead with Kind Designs. I work on a lot of our government-led projects, but also managing projects from start to finish. So a living seawall is really at the future of marine construction, and we want to work with all the contractors locally to be able to bring this future of marine construction to life with living seawalls. And these are 3D printed concrete walls. They're a one-to-one replacement for traditional concrete wall, just like precast, in strength and everything. But what you see here that's unique is an artificial reef structure incorporated into the face of the wall. This provides a few benefits that I'll go more into later, but one's water quality improvements. The second is creating habitat for marine life to foster and improve biodiversity. If you have a client that wants to see a lot of fish or life around their dock, it's the perfect solution. And then along with that, there's permit incentives all around the state that these living seawalls are starting to secure. So that can help you guys leverage projects even further. To provide some background on Kind Designs and where this vision came from of innovating coastal infrastructure and creating a 3D printed living seawall, we are based in Miami now. That's our primary facility, and we are sitting 50,000 square feet on the Miami River. You can see our facility in some parts of this video, but we started with only an idea and really one robot. Our CEO and founder was actually formerly a lawyer, so totally different background, nothing marine related, and she was living in Miami Beach. And like a lot of us around the state, she was living there for 10 years and had experienced consistent flooding. And even on a sunny day, she would have to go and move her car away from the street, and just so the car wouldn't flood down the street. And so she started to explore what was defending our shorelines, our homes, our properties that are so valuable to us. And this is when she came across your traditional seawall structure. There's two main things we identified about your seawall structure. The first being that this infrastructure is aging and failing all around the US and even globally. The second thing is that this coastal infrastructure product can take a lot of time to manufacture and make, as well as a lot of materials and labor. We looked at innovating this with 3D printing, so now you can print an entire project in just one room. We can load up that project, say it's 100 linear feet, 300 linear feet on just one barge, and ship it out to you guys from our site in Miami. Or even with our robots, we're able to print an entire project on site. So our solution brings in the world's fastest 3D concrete printer. So for a 10 by 10 panel, we can complete this in just 1 hour and get those panels to you within 3 days of turnaround time. And we also have the highest resolution 3D concrete printer. There's a few benefits with this, the first being that it gives us great freedom of design. So in Miami, where we're based, we're mimicking the natural environment to bring in more marine life, to bring in those water quality benefits and dissipate wave energy. But we're also able to create really custom and beautiful designs. We've had clients that come to us and say, we're a hotel on the waterfront and we want to create something beautiful and unique. Or a city and a municipality comes to us and they want to create City of St. Pete or something in the wall like that, something crazy. We now have the capabilities to do this and create this by just plugging in a unique design. And so working with you all, we're able to really plug in something customizable and offer that to your client. And then additionally, just as your traditional seawall, it plugs into any concrete seawall project. It's structurally identical. You can use any type of rebar, and there's added benefits absorbing additional wave energy. Compared to your flat wall, it absorbs 50% more wave energy on impact. And then this helps with reducing turbidity and scour at the bottom of your seawall, and also reducing overtopping into the land side. And for all the benefits that you get with these seawall panels and our 3D printed living shoreline structures as well, there's no green premium. People hear the word eco-friendly, they hear sustainable, and they're gonna go, this is gonna cost me a crazy amount, there's gotta be a green premium. For our products, there's no added green premium for all these impactful benefits that you get. So we started out with the living seawalls, which was the first thing we were 3D printing, that replacement for traditional concrete panels. And then we noticed there was a need for other products to enhance an existing seawall. Now we have the living seawall tiles and then the living shorelines. So these are really site-specific solutions. We're doing projects in New York and in Florida right now, working with different living shoreline structures. So this is to showcase one of our living seawall panels here. You can see just like your traditional panel, they're moved in the same manner. They're picked up with lifting hooks at the top there, and even on the sides we leave space for the cap forming and pouring, and then on the sides for embedment, and even on the two sides for king and batter piles, which is the most common system we see in Miami-Dade and Broward County. This is to showcase how we actually 3D print the panels. So while we're 3D printing the panels, this panel showcases a panel that's 10 by 10, and it's completed in just 1 hour. In the beginning is actually the live speed of our 3D printer. Each layer can be completed in 17 seconds, and one layer cures while the next layer is 3D printed. And while we're 3D printing that, you can see the whole panel, this exterior core is created, and we're putting horizontal rebar in. This is to whatever the engineer specifies. So say there's galvanized steel rebar, that's what we're putting in the panels. We're working with GFRP rebar on other projects, so it really is dependent on whatever is specified. And we're putting in that in horizontally, and then we go and put vertical rebar and lifting hooks. And then we fill that empty space of the panel so it's one cohesive panel. And we're able to ship these panels out in 3 days after we've done that. And at our facility right now, we have this great track system that we've custom designed for our facility so that you can just move panels down after you've 3D printed, so the process just keeps going. And we can really print a whole project in just 1 day. For the dimensions of the panels, whatever the project dimensions are, it's completely customizable. Right now, we see a lot of the standard panel dimensions in our area locally to Miami, and a lot of the projects we've completed have a height of around 12 feet, and they're about 10 feet wide. For our maximum height, our 3D printers can go up to 20 feet, so we are able to manufacture panels that are up to 20 feet tall. And the panel itself has 8 inches of a structural base, and then this mangrove root design you see here on the wet face of the wall actually extends out 4 to 6 inches. So the panel is all still within regulatory codes of 12 to 18 inches for the requirements. And the material that we use is a BCSA mortar cement, and it's 5,000 PSI strength. For the strength of the panels, we've performed testing with University of Miami, and they have a College of Engineering lab that works with FDOT. We've compared our panels to precast concrete panels, and they meet the same strength standards, and actually ours exceeded the strength standards of the precast panels in some scenarios for compressive and 3-point load testing. For permitting, so you start with, we manufacture the panels, we design it working with you guys, whatever dimensions are required, and then when we go to permit, there's permitting incentives that we now have in different cities and counties, but our panels actually can be easily plugged and played into any project. So say you have a concrete project that's already permitted, just like this one on the left side here, you can easily plug in our shop drawing of a living seawall panel and they run it right through the permits. All it takes is a modification at the city building permit. Previously, Miami-Dade County required a modification going through DERM, their environmental agency, and this could take 30 days. They now no longer require that for living seawall panels, so they're used in any project. Now for a living seawall, you can actually just do an as-built. Say you already have a concrete project, your client says, oh, I want to use living seawalls, you can easily make the switch and just do an as-built after the fact. For installation, we try to make it as easy as possible for you guys, so we can either 3D print our panels, one on site at our facility and ship them out, or we can put them directly on a barge and send them out that way because we are on the Miami River. We have these great racks that we actually store them in here. Each rack can hold up to 10 panels, so we're able to move them that way easy in and out. And then our panels include the rebar already for lifting and moving the panels. So you can see here, there's it on the barge. This is out on Venetian Island in Miami. And then on the right side here, this is actually of an ongoing installation in the city of Fort Lauderdale. To show you guys how the installation really works, this showcases how you would move other panels, putting them behind the king piles and just abutting right against that existing seawall. And for all our projects so far, we are only the manufacturer 3D printing all these living seawalls and shorelines. So we work with any different contractor local to the area, and we oftentimes have homeowners or even cities reach out to us and they're like, we want to do a living seawall, and they ask us for contractor recommendations that are local to the area. So we're always looking for ways to work with people that are more local in that area and bring projects that benefit the both of us. These are some of our installations, and you can see the movement of the panels here in the installation. This is in Palm Island and Miami Beach just this year. This is Star Island, also in Miami Beach. You can see them putting in the panels. This is during a new build of the home on Star Island. These projects that I'm showing you right here, Palm Island was around 200 linear feet. Star Island's about 100 linear feet. Bryan Place, this is in Fort Lauderdale. This one was just over 100 linear feet. And then Bay Harbor Islands, this is around 400 linear feet. These are all photos of us in the process during the installation where the panels are already on site. This shows how we actually form and pour the cap. So our panels, we leave that space on the top so that the cap can be formed and poured just in place like you regularly would with panels. And then for all our seawalls so far, we've used a king and batter pile support system. So you can see here, this is where the king and batter piles come into play. We do typically recommend for aesthetics, if you want to stack the batter and king piles, they look a little better and it provides this really beautiful thing for the homeowners. But we've done them staggered as well. So you can see the diversity that the panels can play there. And then this is showcasing riprap. This was actually the first project ever installed with a living seawall in Miami Beach. Actually the first project in the entire world to do a living seawall. So it was a huge showcase and it was on the news in different ways in Miami Beach, and the contractors Dock and Marine out of Miami installed this actually for us. And the riprap here, you can see it comes out 2 to 1 feet, but now a living seawall is completely exempt from riprap in both Broward County and Miami-Dade County. So it provides substantial cost savings on those projects. For once you put in a living seawall, you get all these great benefits out of it, and your client's able to get all these amazing benefits. The first being the enhancements in water quality and improvements in water quality. This is that same Miami Beach project just 6 months after installation, and this actually helped us win a huge project in the city of Fort Lauderdale that's going to be 900 linear feet consecutively of living seawalls, because the client there was really concerned about water quality and the impacts they were having to their canal. They're doing this project as something they're giving back to the community and restoring the water. So we went down to site, we took this video, we got in the water, and we sent it to them, and they were like, there's no way that's real. And they were like, you had to put on those oysters overnight. There's no way oysters are going to grow on that fast. And it's completely real. You can see from the picture. And this has proven this seawall is only 100 linear feet, but an adult oyster can filter about 50 gallons of water in one day. So you can think just what the impact of one living seawall has. From everything from our structural backing for our seawall panels to the living seawalls, the water quality benefits, the biodiversity enhancements that we're seeing, we're observing this and testing this all with different universities in the area. So we have this data to show and support the panels themselves. So for structural testing, we've done structural testing with University in Miami, showing strengths comparable to that of precast concrete panels, making it easy to plug into any project. And then for looking at what marine life we're seeing, we're doing ecological monitoring with FIU. We've already seen 36 different species, and they're already seeing indicators of coral growth right around the seawalls. So we're bringing back this marine life way faster than you would typically see. And we've also been doing some work with the Navy. We did win a grant through NAVSEA to work on them with some pilot projects and research testing too. So that was our first product, our living seawall panels. It's an entire replacement for traditional concrete panels, but then we noticed there was a need for something that you can enhance an existing seawall with, whether it's vinyl, steel, or an old concrete seawall that you want to upgrade and enhance. And this actually came out of a public park project that we just completed in the town of Longboat Key. They actually have a ribbon cutting on October 22nd. I think if anyone lives over in that area, if you're interested in stopping by, you definitely should make it over. What you'll see there is actually these living seawall tiles in the middle that mimic mangrove roots. So living seawalls provide all the same benefits that your living seawall would, but in a modular tile system. And we have everything from these standalone tiles. I've brought one up here, and if I can lift it and carry it, anyone can lift and carry it. They're only 30 pounds. Some of them are 50 pounds, but for the Longboat Key installation, took just 2 weeks and only 2 guys in the water. And then those are our 2 main tiles that you can add to an existing seawall. We also have these pile jackets that you can surround and encapsulate a pile itself with, providing that closure around the pile and protection from degradation, but then also this great benefit of restoring the water quality, marine life, and also enhancing aesthetics of the area. For the tiles themselves, just like our living seawalls, these are completely customizable. So any dimensions or designs, we customize it to your seawall, the height of your seawall, and exactly what they want to see. Like I said earlier, these tiles are modular, they're lightweight, so they're easy to move. Our mangrove root design tiles, these are 2 square feet, and they're about 45, 50 pounds. And then our organic tiles, they're more circular or organic shaped, and they're only 30, 35 pounds. We do reinforce these with basalt fibers, so they're still structurally reinforced, even though they're not the seawall itself. And they're all 2,000 PSI strength with material that we use, and we're actually partnering up with E-Concrete. They have a great bio admixture that you can add in to materials to make it even better for the environment. For permitting and installing these tiles, permitting these tiles is really easy. You only have to have a city building permit and an exemption from FDP. For our Longboat Key project, it took less than 60 days to permit that project for 300 linear feet of wall covered in mangrove root tiles. The tiles themselves are installed in a few ways. The first being by using lag screws that you can see there and actually bolting them into the wall itself, or by using marine grade epoxy if you're not looking to go into the wall itself. The project Longboat Key, these are actually plans from that project, and you can see they bolted the living seawalls directly into the vinyl seawall. This is that Bayfront Park project I was talking about. You can see the wall itself is completely covered in these mangrove root tiles, and the tiles are still underneath that cap area. So you get all these benefits of a living seawall without it protruding out further from the cap and having to go through permitting headaches. So we make it really easy to plug this in. And this site right here, something that was really unique we didn't know about before is the vinyl. When water was splashing in and it was creating a lot of noise and creating this bounce back and kind of splashing over into the park area. And a lot of residents were kind of aggravated by some of the noise, so these panels themselves have helped reduce that noise as well. Those were our first two things. So we started with living seawalls, went to living seawall tiles, and now we're noticing a great need for customized living shoreline areas. Living shorelines are growing everywhere, and we're now customizing to each site. What's unique and so great with 3D printing is, say if you guys were to get a project come to us and say, can you manufacture something of this size, these dimensions with X, Y, and Z holes or shapes or spires on top of it? With 3D printing, we're really able to customize that and make some super unique designs. Everything from unique artificial reef structures with all this added surface area on it to oyster reefs. We've actually deployed these oyster reefs in New York, and they're outperforming other oyster reef style structures that they've used in the New York harbor before in just 2 months. And then finally, our planters, these can be used either upland or in the water. If you're struggling and you are trying to get mangroves to take root, but they're getting consistent wave action and damage, this is a way for you to encapsulate that mangrove, provide it some space and time to grow, and then it will grow over, and eventually you're left still with this great benefit of this design left in place, protecting the mangrove and able to blend back into the environment. And all these designs are custom for different projects, so these are just some showcase examples of what we've done before, but we're able to really customize to the site itself. And we do have a team in-house that works on each unique project. So for example, these oyster reefs for Governor's Island Reef in the New York Harbor, Billion Oyster Project actually reached out to us. They're a huge nonprofit working in New York, actually one of the largest working on oyster restoration specifically, and their goal is to bring 1 billion oysters back to the New York Harbor by 2030. They wanted to work with us to create a design that would give them even more surface area and space, along with some other benefits like this flat base that we developed with them, reducing the design itself from rolling over or tipping. And we created all these custom features that you can see here, and they're really loving it. They're looking forward to getting more and more from us as we move on in the future. Now, what are some incentives for all of these products that can help you win projects or can help with bringing in living seawalls and making it a better deal? So first being that they qualify for environmental mitigation. In Broward and Miami-Dade County, they're completely exempt from the county level mitigation. Usually you're required to go out with riprap a large amount. In both Broward and Miami-Dade, a living seawall does not require any riprap. This can help with permitting headaches and mitigation further at the state level, but it also provides substantial cost savings for the project. There is still one bead that's required for the seawall just to go along the footer there from FDEP. Also unique to Miami-Dade County, the county itself passed legislation bringing together contractors, engineers, and everyone from the local area, because in Miami-Dade County, if you've ever put in a seawall there, it can take up to 4 years. We had people saying that it can take them 4 years just to permit and get a seawall installed. From that, contractors, engineers, and a commissioner all came together to expedite this process, to remove DERMS regulations a bit and make the process a lot faster. So now you can get a seawall permit in Miami-Dade County just in 90 days. This might be more regular for other areas around the state, but this was huge legislation for Miami-Dade County. Like I said earlier, it was taking like 1 to 4 years just to get a permit in Miami-Dade County. Now also in Miami-Dade County, no modification is needed for living seawalls. You can plug in a living seawall and just do an as-built straight from concrete. And then living seawall tiles, what I showed you, our second product, you can actually get a permit for these in just 10 days. It's a very fast process to just provide an enhancement to your seawall. And with all that, Miami-Dade County, there's other areas in the county and then in Broward County that are providing permit fee rebates for a living seawall. This is happening in North Bay Village, City of Fort Lauderdale, and Coral Gables, where they're all providing 20 to 50% permit rebates. So you're getting discounts on those fees if you do a living seawall. Our facility and where we manufacture all our panels is based on the Miami River. You can see in the image on the right here, we're growing out. So just 2 years ago, we had only 1 robot. Now we have 3, and we're expanding out and getting more robots this year as we get larger projects. We are located 5 minutes from the airport, so if anyone ever wants to come by and see it in person, please come on by. We love to host you. And then our production capacity right now, we're doing about 50 seawall panels a week, but as we get more robots, this can ramp up. Like I said before, we can even 3D print just 10 to 20 panels now a day. And then for our tiles, that's really dependent on how many techs we have working. We can ramp that up really quickly. The Longboat Key tile project was over 400 tiles, and that only took 2 weeks to manufacture. And for delivery, we can either do it by truck or by barge. Just behind those panels is our waterfront and our docking space that we can give you out panels from that site. Our team right now is 8 people, but we are growing. To highlight, I already highlighted our CEO and founder, Anya Freeman, came from a completely different background, and a lot of people thought this was just a crazy idea to 3D print seawalls. But now we're getting so many projects today, so you can see all the benefits that are really coming from it. And then Jeremy Morris, our COO, is actually an expert in 3D concrete printing. He was 3D printing concrete houses out of Texas before this. You can imagine it's a lot easier to 3D print a wall versus an entire home. So he brings that expert science into our material and taking it to the next level of how we can even better our designs. We are working with partners, everyone from research facilities and universities to the DoD and to nonprofit organizations and municipal partners, as well as different tech hubs in Florida. That's an overview of living seawalls, and I know it's a lot of information, but I'd love to answer any questions you guys have for how these work and how to install them or anything. And thank you so much also for your time today. Yes.
Are you filling the inside the profile before you deliver them or ship them, or is that being filled on site?
So we do fill them, that empty space that you're talking about, we do fill it before we ship them out. So this empty space right here is what you're talking about. We do fill them and then we send them out. We fill it with regular 5,000, 6,000 PSI strength concrete, usually from Ready Mix or like Cemex or somewhere.
What do you do, the lifespan of these things, eventually they have to be replaced. What are the agencies going to do if you have endangered species, corals, things of that nature growing on it? Are they exempt from not being able to re-permit or?
Right now, that's a question I don't have the exact answer to. It will be something regulatory that we're working on figuring out. Right now, the seawall lifespan for these is expected around 70 years. So for the lifespan of the seawall, you have a lengthy amount of time. But when it does come to where you need to put in a seawall, a new seawall, I can imagine it'll go through right now the same permitting process that you would with other seawalls, requiring the same mitigation, but actually with our seawalls, potentially there could be areas to chip off that seawall or move it and take that reef structure that you have on the face of the wall and turn it into mitigation. So maybe in the future you'll be able to do that mitigation on site rather than having to take it somewhere else and do it off site.
You can make them in any width?
Yes, we can make it in any width. With our 3D printer, we're able to really customize the dimensions to whatever is required.
I want to know if you're going to eat one of those oysters on the East River. As far as the regulatory, it's been looked at about the state of the Corps, the other state federal agencies.
Yeah, that's a great question. So all of our seawalls have been approved by FDP, the U.S. Army Corps, and U.S. Army Corps and FDP are both interested in the mitigation value our seawalls can actually provide in place. So qualifying for environmental mitigation potentially in the future in place rather than having to pay mitigation bank credits or do it off-site. This is something we're looking at and exploring more so in like pilot projects with them and talking through the process, but they have approved all our plans previously. Mm-hmm.
You're the only department you have any kind of, I guess, expedited process, or expedition, or, sorry, I lost words here. Durham is the only department you've worked with to expedite the permitting process.
Yes, so Miami-Dade County is, since that's where we were based, when we started to get more involved in the industry, the contractors we were working with and the engineers were like, the biggest issue we face right now is permitting. And a commissioner became really passionate about this issue with the seawall industry in Miami-Dade County, got involved. There were roundtable sessions with contractors locally to the area and the engineers, and we really worked through this process in Miami-Dade County to make it a 90-day permit process, because Durham was putting a lot of pushback and making it longer. There was no review timeline on Durham. So they could kind of just go and go for however long they wanted. Durham is the only one that we've right now changed this legislation with for the county. The only other county, Broward County, where you get other incentives like that is the riprap exemption from the living seawalls too.
And that was only in Broward, on the riprap exemption, correct?
The riprap exemption is both Broward and Miami-Dade County. Yeah, thank you. Yes.
Can the panels be handled without being filled if we have lighter equipment or difficult access or tighter staging areas? Can you ship to shell, for lack of a better term, or is it not able of being handled without the steel and concrete profile?
Currently, right now, we are developing a design where you will be able to move the panels before filling them. Right now, we prefer to fill them on site and send them out just to ensure the structural integrity before we send them out, because we do some testing on site, but we are working on a design where you'll be able to fill on site. Yes.
Have you printed anything on a job site yet?
No, so we have yet to print anything on site. We have run through our operations of like what we would have to bring on site, the upfront costs. Obviously, it has to be a larger project, but for us to open up a facility or operations for just one robot, all it runs on is one generator. So we're able to operate power-wise pretty easily. Yeah, of course. The tiles attached, so depending on the substrate of the seawall that you're attaching it to, whether it's concrete, vinyl, or steel, for vinyl seawall, we've so far used lag screws or in a combination of marine grade epoxy. The engineers that we worked with for that tile project wanted to use a mechanical connection to attach the tiles to the seawall itself, but we are able to just use marine grade epoxy because of how light the tiles are. Or for steel, the option for that is stud welding or a combination of marine grade epoxy as well. So this is an actual photo of the engineering documents for that bayfront park, where you can see the screws right here that actually go into the vinyl sheet piling itself through that reef tile. And in our tiles themselves, we actually put like bolt holes in it, and we over-engineer it so there is a bit more space in it itself. If that answers your question, because there's all different materials you can use, so depending on the substrate and also what the contractor is interested in using, what we're specifying as engineers. Any other questions? Yes.
The pile jacket screen that you make, what are you using for reinforcing in that?
Yes, so in that we're using fiber reinforcements. If you've ever seen the individual fibers, yes. So it still like has some structural support to it, but the concrete material we still use for that is 5,000 psi.
It is the 5,000.
Mm-hmm.
Are they cast or 3D printed?
So we 3D print the design itself, and then we do cast them. So the textures that you see on it, I have one out in my car if anyone's interested in seeing it too. Couldn't bring both in, but so we 3D print the design itself, and then we reverse mold it and use precasting for that.
So are the moldings cylinder when we get them for the field?
Yeah, so we would send you all the material like just ready for you guys to install. You wouldn't have to do any of the molding or anything yourself. Like we send you 2 pieces and they just go together, and they have different bolt areas. I don't think I have a good picture, but they bolt through on the sides, and we also have placement in the middle if you want to bolt it directly into the pile.
How tall are they normally? We see all the damage done in the tidal zone,
Mm-hmm.
worms and everything attached to the bottom, but some spots are pretty deep.
Yeah. Right now, the pile design that we've developed is probably about this high for each piece. We can make that a lot bigger. So the project where that design really came from, they were about this big for each piece. Yes.
How do you quantify, what's the unit measure, or what's the difference? A flat concrete wall still gets growth on the front of it.
Mm-hmm.
Right? It's not like these concrete walls don't have regrowth, from the mud line up to the mean high water line. How do you quantify or substantiate if the growth y'all are generating is better than a flat face concrete panel?
Yeah, that's a great question, and one we get a lot of the time, because oysters, filter feeders, they still just love concrete material. What's really great about our seawalls is, one, it's faster recruitment, so you're getting that recruitment a lot faster than you would for a usual flat seawall. And then we have a lot more surface area on our seawalls. So our concrete panels actually have 2 times the surface area of a flat concrete seawall panel. And so we're quantifying how fast things are recruiting to it, the number of species that we're seeing in that space too, and how fast they're coming into the space. So by providing more surface area, we allow for the recruitment of a lot more species too. So you're able to see a lot more oysters than you typically would on a flat wall. And those deep caves that you get with a living seawall provides them a lot of space to hide. This is a great space for actually juvenile fish species to hide. So in those deep caves, some of them are like 6 inches deep. You can stick your whole hand in there and it's a great spot for oysters to settle, and then it's a great spot for fish and even lobsters and crabs to hide in there. So by creating these deep caves and textures and more surface area, we're seeing more and faster recruitment. Any other questions? No? No one? I have a feeling there's some more. Okay, well, thank you so much, guys, for your time today. And if you have any questions, please feel free to ask me.
Being a consumer, I'd say we're all consumers and customers to different products, different companies. When we're picking a product and picking a company we want to use, we're looking at who they are. Do they share the same beliefs? Do they share the same wants, needs, whatever it may be? We're wanting to know who they are and what they're selling us. So the cool thing about marketing is we can use it for our own, whether personal, business, maybe you own a business or you do sales. You can use it to project your voice and define your company. So being here at the FMCA means that we're looking at a lot of marine industry problems, whether it be erosion on a property of a waterfront home, maybe it's wanting more land on that waterfront. It could also be maybe you have a boat, need a boat lift, dock, piers, seawall, dredging, lots of different options. And so part of that is we want to use it to push those products out for the consumers to let them know that you can do it. Before we get started, I do want to kind of get an idea of where everyone's at with their marketing. So who here, whether you're the owner of a company or you work for a company, if you can raise your hand, let me know if that your company has a social media page. Okay, all right, some of them. All right, and then also if you have personally used marketing tools such as like Canva, or maybe you've posted pictures on your page, video editing, if you can raise your hand if you've done any of the marketing yourself. Okay, we've got some. All right, cool. So then let's get started. Today I'm going to talk about digital marketing, some of those tools, the AI tools, because AI is becoming a big thing today. So we're going to touch point on that, and then we're also going to talk about how to get you started on doing it yourself. I've given you a big packet. It seems like a lot at first, but I promise it's not. You'll kind of break it up. So the first thing included in your packet is your first 30 days of marketing. So for those of you that maybe don't have a social media page yet and you want to learn about that or want to get started on that, this will kind of walk you through those touch points of where to start and what to do. Or maybe you do have that page established and you kind of want to grow it a little bit, or you don't know where to go from here because you just built it. This would be great for you to get started. So the next thing in your packet is defining your market. So like I talked about is we're looking at consumers and their needs and their wants. So we also want to learn who they are, who we're talking to, and how we can talk to them. So this worksheet is great for you to walk through, figure out your audience. So if I'm looking in the marine industry, maybe I'm selling a boat lift, I want to learn where I'm selling to, maybe watch my customers' addresses, see where I'm selling to. Are they getting more lake lifts? Are they getting more lifts that are on the Gulf? You want to pay attention to that and see where we're marketing in those areas, because I don't want to market a lake lift on the Gulf. Probably wouldn't benefit me at all. So that's kind of what this is going to do. It's going to help you to decide where you're going to market and how you're going to market to your audience. Next, we've got the 30 days of marketing, and I call this the next steps. So maybe you've already walked through the first sheet, or you're already past that and you don't even want to look at that. This will be great for you to kind of get started on the next step, and you're going to go through your social media, clean it up, make sure everything's up to date, and it'll walk you through those steps, maybe building content buckets. So content buckets are great for deciding how you are marketing. So you'll have your culture posts. When you're posting, you're going to have different types of posts. You'll have product post, culture post. It could be a range of anything. You can choose how you want your content to look. And this is just going to help you break down that content. I've also provided a worksheet on useful resources. There's a lot of technology and tools developing today. Every day it feels like there's something new that's come out, whether it be social media outlets or just the tools themselves. This has a not definition, but explained beside it of what it is, so you can figure out what you're looking for and how it can help you. You don't have to use every single one of them. I don't even use every single one of them, but it does give you an idea of maybe you're looking for something here, but not looking for something there. It breaks it down. And then the final 30 days of marketing. So this is actually 3 months if you break it up and you do want to do all three. It's broken up into 4 weeks on each 30 days. And it just gives you a small task. So I promise it looks like a lot when you're looking at the packet, but if you just do it by week, it's super small, super simple. This is for the kind of more advanced if you've gone through the first 2 and you're ready to really step it up, or you're already past the first 2 and you just want to amp up your social media and your posting. You can do that through this. It's all pretty simple. It follows itself. Next, we have the SMART goals. So when we're marketing, we want to look at what we can do next. So maybe you want to generate more sales leads, or you want to generate more followers. Maybe you just started your page up and you're like, hey, I want to hit a goal of 1,000 in this amount of time. Or maybe your goal is 1 million followers. That's going to be hard to hit, and so you want to break that down into a goal. So maybe in 2 weeks, I'm going to hit 100 followers. And this is going to teach you how to break down those different goals in order to reach them in a certain amount of time. That makes, to me, motivation is built by confidence. So as you reach those goals, you'll feel more confidence in your marketing and presenting your products. And the last thing is a good short write-up. So a lot of you probably don't think about this, but when you're building your website, or if you've seen Facebook, Instagram, LinkedIn, a lot of these sites have a description of your brand and your business, or maybe products. So this is going to teach you how to write that to market it directly to your audience. So if you do your defining your market and then do this next, you're able to really connect everything together to make sure you're pinpointing who you're marketing to. So now let's actually talk about marketing. So what is marketing? Marketing is really being the voice of your company. If you look at a Facebook page that has no post, maybe you Google a company and they have no website, no post, no social media, you're probably not going to go to them. So this is going to be big on making sure you're sharing your product, sharing your work, sharing your service. If you get reviews, this is a great way for customers and consumers to see that. So a lot of people think that you don't need to start marketing until your business is built up, but I see it differently. In order to build your business up, you need to start marketing to get your brand out there. So maybe you've just started your business and nobody knows who you are. Get your business cards, get your Facebook page set up, maybe start with just one social media outlet before trying to jump on all of them that's out there. Start with one, start telling your friends, tell your family, share it, share it, share it, share it. Word of mouth is wonderful, but start somewhere. This is a big part of it. Like I said, trying to be everywhere at once, you're gonna really feel like you don't know what you're doing, overwhelmed. Start small. So there's lots of many outlets that we can see marketing being touched. I would say probably the biggest one for the marine industry I see is Facebook, LinkedIn. You don't see a lot of Instagram. It's a younger demographic. So unless it's really, the marine industry just is more Facebook and LinkedIn. I've been investing more in TikTok and Pinterest. It's a long-term kind of market, but Pinterest is really long-term, and so we're kind of getting into that a little bit, but developing on that, so touch back. Ads are really great, magazines. You see a lot of magazines today that you can drop a quick ad in, and those will last a really long time as well. Those get put down on, what are they called, the table, coffee tables. Different businesses, you see them passed out, big events, local events. A lot of local communities have local magazines. I know I'm from Pensacola, and we have an actual Pensacola magazine. So check with your city, or check if maybe you have like a marine industry magazine near you, and see if that's something you can look into. And that's, again, finding your audience. So maybe if you sell more to younger people, maybe magazines aren't for you. If you sell to older people, newspapers and magazines might be good. I think Facebook is a good in-between for that demographic. You see a lot of older people and younger people on Facebook now, so we can kind of mesh that. Billboards, expensive. So unless you're a big corporation, I would say for this industry, not so much. But it is a possibility. Again, all up to you, and that's defining your audience. And once you choose your audience, then you can see how you can budget correctly and see where to spend your money on marketing. Some tools that we can use. So when we're talking about designing, it's super easy to throw up a picture, but we want to make sure we're catching eyes. So did any of y'all raise of hands, have y'all seen a billboard maybe on interstate every single day that you drive, and you can just tell me like something on that billboard that it says because you see it every single day? Anybody? No? See, in Alabama, we have this one, is it Alexander Shanara? Man, he posts billboards every single road. So it's eye-catching though. The point is you want to be eye-catching. So when you're on Facebook, you want to have something like a logo. You want to have big words. Even just a photo works, but we want to make sure we're getting that caption out there to really catch that algorithm. Everything today is algorithms. It's a lot. So some things we can use are Canva. It's going to be super simple. It's free. You can pay for Pro, but I recommend if you're just starting out, start with that free version, get used to it, play with it. They have lots of free templates as well, so if you don't know what you're doing, you're not design savvy at all, they've got lots of free graphics. You can just pop a photo in, pop your logo, pop your information in there, and it's super quick. Save it and share it. CapCut, maybe you've got some videos, you can do a before and after of those seawalls or any products that you're building. Maybe you're doing some redesigns, whatever it may be. You can take some videos and quick edit. They have templates as well that you can put together. And all of these are listed on that useful resources list. And then some of these other ones, I don't use the Kittl or look at as much, but you can use those to get some ideas of templates. Again, if you're not design savvy, there's lots of options out there where they already have it ready and you just have to drag and drop. And then Pexels is great. If maybe you don't have as many photos, but you do want to start posting, you can search for like a seawall or a dock and then add your information that you want and post on your page. So this is going to be great for when you're writing your captions or you're writing emails, your branding, any of your product guides. You can use these. ChatGPT is a big one that's becoming very popular. I'm sure all of y'all have heard of it. ChatGPT is great if you're looking for maybe caption ideas. You can put in there, hey, I'm doing a post about a brand new dock I just did. It was a custom. I used this decking and I have a boat lift in there. Give me an idea for a great caption to catch someone's eye. And they'll give you lots of different options. Answer the public is really cool. If you look to that picture right there, you can type in any kind of, maybe you want to look up seawalls. It'll give you all of the recent searches that people are searching with that keyword in there. So you can get an idea of what's popular right now. Maybe they're talking about a certain type or whatever it may be. So that's going to be great for getting an idea of your audience. Grammarly is one of my go-tos. I've been using it since high school. If you're writing emails every day or you're talking to customers every day, or even if you're writing those captions on your social media page, it links right to your phone or right to your computer. So as you're typing, it corrects you. It'll give you options. So maybe you're talking to someone more formal or you want to be more casual. You can choose that tone and it'll correct you based on what you chose. So that's super quick, and that usually is free, but you can upgrade. A lot of these, you know how it is, free with, and then you have purchases. Another good one is Google Trends. You can go on Google Trends and you can type in keywords and it'll tell you everything that is trending along with that keyword. So it's similar to the Answer the Public. So another idea, so let's say you're not design savvy, but you also have no idea what to post, where to start. This is a great option. It is so simple. Go on your phone, go on your computer, go to Google and just type in one keyword. It'll give you all of the most popular searches with that keyword. And so then if you look here, one example is I typed in seawall build. You can see where it says build seawall retaining wall. So then you can make a post, what is a retaining wall? That gives your audience, it shows them that you have credibility, you have knowledge on your product. It gives them information about the product, tells them what it is and if they may need it. Another example would be, it says, how long does it take to build a seawall? So obviously this is a popular question, so now we can answer that question. My team can get a seawall built in blah, 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 blah. Or this seawall took blah, 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 blah. However long it took, you can post, and that then answers that question. So you're able to kind of connect the dots for these consumers to your product. If anyone knows what SEO is, it's search engine optimization. So if you have a website, you want to make sure we're putting in keywords. So then if you see all these words right here, that's going to then shoot your website to the top of the Google search, and they'll see yours first based on those keywords. So search engine optimization basically helps people find your website. Now, if you don't have a website, this doesn't really apply to you, but throughout your website, you have different pages. You want to make sure you have keywords, links, pictures, images. This is going to really build. If you look at Google, there's 70,000 pages at the bottom when you get to the bottom. A lot of websites we don't see, and that's because it doesn't have a lot of SEO. A lot of people actually pay to push their page to the top. So part of that can be, you can look at different percentages to not only pay, but push your website higher by building that kind of, I like to call it background. It gives your website credibility for those keywords. So if anyone would like to, we're going to walk through Canva. I just now realized it's kind of backwards on me, so bear with me. All right. So if you go to Canva, you'll log in. You can click here on social media. It's going to give you different options. So you'll have lots of different options. Maybe you're posting on Instagram, posting on Facebook, or you want to make a flyer. So many different template options in here. But today we're going to talk about an Instagram post. So you'll select it. It'll give you a preset sizing. So you won't have to resize anything once you get to the app. It's being a little slow today. All right, so then once we do that, we're going to go to Elements. They have lots of preset free images, free text, and free graphics. So it makes it super simple. We're going to search doc. And so I'm going to find one of the free ones. Use this one right here. I'm going to select that. And then it should have an option. If you're on your cell phone, it'll have 3 dots. You can select the set image as background. So now it's already sized for me, already has what I want. And then I'm going to add some text. And let's say I don't know what kind of font I want, but I want something simple to just catch an eye, but really focus on that doc. I'm going to use this one right here. I cannot see, so if it looks all wonky, I promise it doesn't look like that. All right, so up here, we're going to really focus on docs. We're going to say design, build, and let's say quality, because that's what our docs are, they're quality. And then we're going to move that to where it looks all nice and formal. And what are some options we offer? Well, we offer docks, piers, and boathouses. And we're going to move it up a little bit just to make it all nice and neat, and you're done. That is how simple it is to hop on one of these websites and make a post for your company or your brand, and you can do it yourself. Easy peasy, lemon squeezy. All right, that's all I've got. Does anybody have any questions? Yes.
Yes, once you have done all the marketing that you've described, how do you determine which, if any, are having the result? What systems would you recommend?
Yeah, so a lot of companies, I think there's some on the useful resources list, actually have analytics. Facebook, you can actually look at your insights. Instagram, you can look at your insights. LinkedIn, you can also pay like other companies outside of it to like watch your socials and show you the different, it'll give you an insight feedback every month or every week, however often you set it, and it'll show you your growth over time. Part of that is engagement. So I don't know if you see a lot of these companies, but they'll give away free coolers, free cups, free koozies, free hats. But one of those catches is like, share, comment. What that does is that adds to that algorithm, which then boosts it, so you'll see those insights shoot up, and so it puts it to the top of your page. Anything else?
How do you track, though, that an actual customer came from that resource or that?
That would more so you'd have to ask the customer. A lot of people do surveys, like they'll say, how did you hear about this? Or how did you hear about us? And that's when you see that kind of like in a review, or you can ask the customer themselves. I guess it depends on how you're set up on your website or your socials. A lot of people say though, in the beginning stages of marketing, they just ask their customers, how did you hear about us? Was it through socials? Was it word of mouth? Was it a magazine? And they just kind of talk to them. But I guess again, it depends on your customer base and how you're set up. If you have a website, a lot of people will have a section that says leave a review. Yeah.
Do you use any programs to post multiple cloud posts at one time?
Yeah, so I've used Cloud Design, Cloud Campaign. You can use Hootsuite, Social. There's a list on there, I think, that has those on there. The difference is really finding how many. If you're one person, you're one company, and you want to post to multiple, most of your ones that are free, they should be listed on there. I tried to find the free ones. I use ones that I pay for, but a lot of those free ones are pretty simple. It's like one brand, set multiple accounts, and you'll log in, and you can actually schedule months ahead and just schedule those posts. But you just have to search. I would search multiple account posting, or just search Cloud Campaign, and if you search Cloud Campaign, it'll pull up with all those different options. Anybody else? No? All right, well, before I go, I will say I do own my own marketing company, so if you see all this and you see those worksheets and it looks intimidating and you don't want to do it yourself, I actually do the schedule and posting for you, and I do the design. So I have different programs set up to where you can say, hey, I want 8 posts a month, and you'll have a flat-based monthly fee, and I can get you guys set up to where I'm designing your post for you. All you have to do is send me the content, and I'll get your captions, and then I'll write everything up, have it ready, and you just have to approve it, and we'll get it scheduled to post. So that is another option if you don't want to do all this yourself. Thank you guys so much for having me, and if y'all have any other questions, or maybe you need some help setting up your own marketing, feel free to call or message me or email me, and I can help you set up with whatever you need.